Okay, good afternoon everyone. We are going to start with our session after lunch. That's always the most difficult one, because then we all can sleep and the presenters have to keep us awake. We have now 4 presentations, and we got a question from the audience that during the questioning for the presenters, you will have to use the microphone. So I will give you the microphone before you give the question. Our first presentation will be made by Petra Ross. Petra Ross is a student from Delft University of Technology. She finished her MSc several years ago in civil engineering, and she's working now on a PhD, and she's still working on it, but almost finished. So we are waiting for the final thesis. And but she's already working for a big consultant company in the Netherlands, ARCADIS, at the moment. Her presentation will be on online monitoring of ozonation, and I will give the floor to Petra.
Okay, thank you, Luc. Okay, good afternoon, everybody. I hope you can stay awake just immediately after lunch. I'll do my best, at least. First, I would like to acknowledge my co-authors, Alex van der Helm from Waternet, Joep van der Broeke from BeNeLux Water Solutions, and Luc Rietveld, as you just see him, from Delft University of Technology. This research has been carried out within the Techno project. It's a 6th EU framework project, and together with, in close collaboration with Delft University, where I did my PhD and trying to finish it if he cooperates, and BeNeLux Water Solutions with use of help by means of the S-scan, UV Vis-spectrometers, and Waternet, who provided us the opportunity to do a lot of experiments. So first I would what I will tell you about today is I'll first give a brief introduction into the ozonation system, then on the online measurements. Then I will tell you something what my objective of the study was, the experimental setup, the results, and I will finish with the conclusions. So if we go and look at ozonation, the primary aim of ozonation is disinfection. And next to that, during ozonation, oxidation of natural organic matter takes place. And as a result of that, biodegradable components are increasingly present in the water, which is measured, in our case, by means of AOC, assimilable organic carbon. And this is a parameter which is very important that we remove this parameter, because in the Netherlands we don't apply any final disinfection by means of chlorine. So we have to make sure that our water that goes into the distribution system is biologically stable. And therefore the AOC concentrations have to be below 10 micrograms per liter. And then next to that, of course, a big aim of ozonation is the improvement of color, taste and odor products. So if we then look at ozonation, yes, thank you. The ozonation is influenced by the raw water quality. Coming into before ozonation, for instance, if you use surface water, natural organic matter can be present in the water, which is a scavenger of ozonation. So ozone first reacts with natural organic matter, and then afterwards, if there's still ozone available, can be used for disinfection of organic micropollutants. And next to that, so the influent quality really interferes with the ozonation and determines the amount of ozone that is required to achieve sufficient disinfection. Next to that, also the ozone influences the biological stability. And of course, a bromate can be formed. So it would be very good that we have the most optimal setting of ozone dosage to make sure that we have not a lot of byproducts being formed and that we achieve sufficient disinfection. So how can we do this? Then what we would want to do if we want to optimize the ozone system is we would want to look at the control options we have for ozonation. And for ozonation, what we can do is we can change the ozone dosage, and with that determine the amount of disinfection reached. In what we normally would use is the CT value. This is the concentration of ozone in water measured times the residence time. And with this, we can determine the disinfection we have achieved. Next to that, AOC is also a pretty important parameter because this determines what the other treatment steps require to do so to make sure that we produce biologically stable water. In this graph, what you can see is you can see in black the ozone concentration in water and 2 dosage points. Therefore, you see the concentration going up. And then as a cumulative parameter next to that, you can see the CT concentration being calculated. So, but if we would want to go to direct control of ozonation, we want to have some online indication on how the system operates and what we should do. With that, then we can directly influence the ozone concentration. So if we look at the availability of online measurements, we see already that a lot of research has been done on the UV decrease and the ozone concentration in water. And next to that, that's for determining the ozone concentration and thus the CT value. And next to that, we also know that there's quite some relations have been found between the change in UV254, so the UV had an absorbance of 254 nanometers, and the AOC formation during ozonation. So these two, or a lot of research around this, indicates for us that it might be possible that we can use the change in UV for determination online of the control parameters we want to look for. So if we then look at the UV absorption ranges, in this research we used the UV Vis-spectrometer, so we measured from 230 to 750 nanometers. And with this, we had the opportunity that we could use a turbidity compensated spectrum. So that means that with an algorithm developed by Scan-Messtechniek, we know for sure that the decrease in UV isn't because of the change or of an increase in turbidity, but it has to do with the other absorbance parameters such as NOM being present in the water. Yeah, so that brings me to our objective of our research. Is we want to have online monitoring of ozonation, and with that we try to develop an online measurement of ozone related to CT values in water to determine the disinfection capacity. And next to that, we also want to have an online measurement of an indication of the formation of biodegradable organic matter. So that brings me to our experimental setup. Our experiments were carried out at Waternet. Waternet is a water cycle company of Amsterdam and surrounding areas. You've heard the name before probably. And it is situated in the surroundings of Amsterdam. And we did our experiments at Weesperkaspel plant, which has used seepage water from the Bethune-polder, and from there on it's pre-treated and then transported to Weesperkaspel, which you can see on the right graph. And there they have a very nice pilot plant. And in that pilot plant, amongst others, an ozonation system is present, where we have, can treat up to 15 cubic meters per hour. It has the same heights as it has in the full-scale plant. With that, we try to be able to convert the results as easily as possible into the full-scale operation. And what we did is we took, for the determination of the CT value, we applied different ozone dosages, and we took at different heights, we took sampling points, and we determined the ozone and water concentration. With that and the known residence time, we could calculate the CT values. For AOC concentration, we took influent concentration, and we took an effluent sample after ozonation, and for both we applied the AOC concentration. For those two sampling points, we also put an online UV vis monitor spectrometer. what we decided to do is that we wanted to use a differential spectrum, because with that we can rule out any changes occurring in the influent and try to get as robust algorithm as possible. So what we did is we determined the influent UV-Vis spectrum, and we determined the effluent, and by subtracting those we have the differential spectrum. And for these values, what we did is that we did a lot of experiments. We did these experiments over the last 5 years. We had temperature fluctuations between 3 and 20 degrees Celsius because it's surface water treatment. The DOC concentration varied between 5.2 and 6.5 milligrams per liter. We had a UV254 change between 14 and 15.8 absorbance per meter, and we also applied different ozone dosages to try and to get the biggest range which was available, which is normally used in drinking water treatment in our system. With that, we determined the multiple linear regression. With that, what we did is we wanted to try and to identify which wavelengths significantly contribute to the change in absorbance and the correlations found. So now what I now do is I'll show you two results. One is the result of the algorithm we found for the AOC concentration, and the other one is for the CT values. So as you can see, we determined an algorithm for the change in UV-Vis correlated to the AOC formation. And there we found that we needed 5 wavelengths. And with those wavelengths, we can quite accurately determine what the AOC concentration is that's formed during ozonation. So here you see on the x-axis you see the change in AOC measured by the laboratory, and on the y-axis you see the prediction of the UV-Vis spectrum to determine what would be the AOC concentration. And the error bars you see are the errors between duplicate measurements of the AOC determined by the laboratory. And then if we would do the same we did for the CT values, so a total of almost 20 samples has been used in order to determine this algorithm. And we can see that we can very accurately predict during this algorithm, we only needed to use 1 wavelength, which shows the statistical significance of the change in UV absorbance. And this will help us because when we want to control our ozone dosage and determine our CT disinfection parameter, normally if you go to a full-scale plant, you only have one small, when you measure, for instance, the ozone and water concentration immediately after dosing, that's already quite small. So it's pretty difficult to determine your CT value based on only that measurement. So based on this, we have a more accurate indication of the CT value which has been achieved. So that brings me to the conclusions. So what we found is that by means of the differential UV-Vis spectrometers, we can use to determine online the AOC formation, an estimation of the AOC formation, and the CT value. And with this CT value, it makes it possible that we can come to a direct control of the ozone dosage in the full-scale plant. And by that means that we are sure that we don't form as many byproducts as might otherwise be if you don't exactly know what's going on. Thank you.
Okay, are there any questions? Rob, can you introduce yourself?
My name is Rob Schotman. I have a question about the results of your pilot installation. Did you compare them with the real installation? Because I did also some research far way back at Kralingen, but there was a substantial difference between the situation in a pilot plant where you have actual it's very clean situation compared with a situation where you have concrete and disk diffusers. did you compare it? And what
at the moment we have put UV spectralizers in place, so we are now at the phase that we're testing how good we can apply the algorithms found in the full-scale plant. However, our experience, or at least Alex's experience, is that he was able to build a model around ozonation on the pilot plant and was able to validate that in the full-scale plant. So based on that, we do think that the results should be easily upgraded to the full-scale plant.
I hope so.
Yes.
Other questions? Joep, no extra questions about the S-scan? Yeah? No questions anymore? Okay, then I would like to thank Petra.